continuous variable, the probability that x is in between a and b is defined as the integral of a to b f of x dx. And f of x is a function of variable x PDF or probability density function. So here you have only one variable, one random variable. What if we have two random variables and we want to find the probability with respect to those two variables? In that case, the joint probability density is defined this way. We say that, hey, you have the probability of x and y, which is defined as the double integral. Here you have two variables, so you get double integral of f of x and y over region D, dA. One example for you. So here you have, if the joint density function for x and y is given as, so let the joint density function is defined as the following. You have your f of x and y, which is defined as a pairwise defined function. C is just a constant, x plus 2y. Your x ranges between 0 to 10, and your y ranges between 0 to 10. Okay. And for other places, everywhere else, it's defined as 0. Question says, find the value of the constant C, and then find the probability that x is less than equals to 7 and y is greater than equals to 2. Greater than equals to 2. Remember that when we are talking about the density function for a normal distribution, the area below the graph is 1. So this integral is going to be, if you expand a to negative infinity, b to positive infinity, is equal to 1. Okay, let us solve it together. So we know that we have a double integral and the area below the graph must be equal to 1. So if you take the double integral 0 to 10, 0 to 10, doesn't matter, the order is not very important. And here you have c times x plus 2y dy dx. It must be equals to 1 because the area below the density function must be 1. So here you have, if I take the integral with respect to y, I can write this c as a constant outside the integral, 0 to 10, 0 to 10, xy plus y squared. Write this down here, 0 to 10. I already took the integral. This is equal to 1. Very well. So this inner integral is 10x plus 100. Now I take this integral with respect to x. So I have 5x squared plus 100x, and x ranges between 0 to 10, and I have c. Outside the integral, it is equal to 1. So it says 5 times 100, so 500 plus 1,000 is equal to, times c, is equal to 1. So my c is 1 divided by 1,500. This is my c. Now I can calculate the probability that x is less than equals to 7 and y is greater than equals to 2. Okay, let's do the calculation here for you. Here you have double integral. So my x is in between 0 to 7. 0 to 7. This is my x. My y is in between 2 to 10. 2 to 10. And I have c, which is 1 over 1,500 times the function x plus 2y. dy dx. I can write this number, this constant outside the integral, 1 over 1,500. Then take this integral with respect to y, which is equal to xy plus y squared. My y ranges between 2 to 10. So let us plug in 10 here. I get 10x plus 100 minus 2x plus 4. So this guy here is going to be 8x plus 96 and dx. This is equal to 1 over 1,500, and I have 4x plus 96 x. Here we have exponent 2, 0 to 7. So if I plug in 7, I get 1 over 1,500. 4 times 49 plus 96 times 7. By doing the algebra, you get 868. 868 divided by 1,500. Let's do the calculation, 0.5787. And finally, we can expand the idea to triple integrals. If your joint density function is depending on 3 variables, so if the joint density function is f of x, y, and z, then we can find the probability of x, y, and z to be triple integral over region E of your function f of x, y, z, dx.